All right, final exam part 2, question number 1. I have a triangle, and I know two sides, and I know its area, and I need to find the perimeter. And so I know, let's go ahead and put some things on here. So I know 8.1, and I know 12.3, and I know the area is 15. Okay, so I don't know the third side. In order to find the perimeter, I need to find the third side. Let's clean this up a little bit. 12.3. All right, so what formulas do I have? If I look at my formulas, I have area of a triangle. Okay, we know of area of a triangle also as 1/2 base times height, but we don't know if it's a right triangle, so we can't go with, saying one's the base, one's the height. So instead, we're going to have to go with assuming it's not a right triangle, and we can use this formula. So our formula, area is equal to 1/2 AB times sine of angle C. All right, so angle C is the angle that's in between A and B, because if I label this side A, side B, side C, angle C is the one that's opposite side C. So here is angle C. So we're going to be finding this angle right here. We're going to find that angle. All right, so we know our area is 15, and then we have 1/2, we have 8.1, we have 12.3 times sine C, and we want to solve this for C, so I'm going to go ahead and multiply this out. I could do all the algebraic manipulation first, but I'm just going to multiply this. 0.5 times 8.1 times 12.3. So 49.815, so I have 15 is equal to 49.815 times sine C. Divide both sides by 49.815, so 15 divided by 49.815, that gets me 0.3011, etc., is equal to sine C. Okay, I'm going to keep all that in my calculator. I don't want to lose any of my precision, so make sure you keep that in your calculator. To solve for C, we can do the inverse function. So we can do C is equal to, or approximately equal to, sine -1 of 0.3011. That's how we get the angle. Okay, so when we move the sign to the other side, it becomes sine -1. So to do that on my calculator, I'm going to use second sine. That gets me the inverse. Now, to make sure I get all my precision, I'm going to use my arrows to go up and capture that. So I'm capturing that and hit enter. That puts it into my current equation, and hit enter again. And, am I in the right things? I am in, why does that look funky? Did I do something crazy? I did something crazy. What did I do? Huh. Okay, I should have gotten 25.58. No, I shouldn't. I should have gotten, oh, that's okay. Sorry. That's in radians. I'm looking at my paper, and I have it written in degrees. Ha! Okay, so this angle ends up being, so C, angle C, so the measure of angle C is approximately 0.306. If we're doing 3 sig figs, oops, I'm off this thing here, radians. Okay, so that's in radians. And now I want to find the missing side length. So in order to find the missing side length, I need another formula. So to find the missing side length, I can do that with this formula right here. I can do that with the cosine rule. Okay, because now I know what my angle is, and I know what A and B is, so now I can find side C. Man, I write too big. This isn't working out too well, is it? Okay, so now I need to find side C. So my formula, sorry, I keep moving my paper off. My formula is going to be C squared is equal to A squared plus B squared minus 2AB cosine theta, or in this case, angle C. Or actually, it should always be a C. Sorry. I don't know why I said theta. It's a C right there. All right, so I don't know what C is, but I do know A. So 8.1 squared plus 12.3 squared minus 2 times 8.1 times 12.3, I'm running out of room, times cosine of C. C is 0.306 radians. Sorry about that. All right, I can put this whole darn thing into my calculator. So C squared, let me make a little thing. C squared is equal to, I'm going to just type this into my calculator. I have 8.1 squared plus 12.3 squared minus 2 times 8.1 times 12.3 times cosine, and then I'm going to go back up to find that previous answer. There it is. Okay, because I don't want to use 0.306 because that's rounded off. So I want to make sure I go back and capture that and then hit enter. Okay, so C squared is equal to 26.888. So what have you. And then I need to square root that. So C is equal to square root it, I can do this. I can use the square root symbol. I'll just do that. And capture it, put it in there, and hit equals, and I get 5.18. Okay, so C is 5.18. So this side right here is 5.18. So my smallest, oops, sorry, there I go, off the edge again. Clearly I am unpracticed. It's been too long a summer, right? All right, so my perimeters, I'm going to add those three together. It's equal to 8.1 plus 12.3 plus 5.18. If I add those together, so plus 8.1 plus 12.3, I get 25, approximately equal to 25.6 centimeters. That is my perimeter. Now, remember, it says smallest perimeter and then largest perimeter. So the smallest perimeter you get automatically. The largest perimeter you got to think a little bit about. So notice we used cosine of an angle here. Well, there is another angle that has the exact same cosine. So if you think about your unit circle and you think about cosine and sine, okay, think about cosine and sine. Cosine is adjacent and sine is the vertical, right? So my coordinates are cosine and sine. Okay, so where else do I have, if I go back to here actually, let's go back to this one. Why am I saying cosine? Let's go back to here. So when I found my angle, okay, when I found my angle right here. I knew sine was equal to this. So if I have sine is positive, okay, sine is positive, it could be right here, or where else could it be? Notice this is my y value. So where do I have the exact same sign? If I flip this triangle over here. If I flip this triangle over here, this angle right here is also going to have a positive sign. Okay, it's going to have a negative cosine, but it's going to have a positive sign. Because we solved for this angle and got this, that would be this guy right here. But there's another angle that has the exact same sign, this angle over here. Well, this angle is this measurement right here. Okay, so from here to here. So notice this angle is the same as this one, okay, because these are reflected triangles. So this is 0.306, this is 0.306. So if this is 0.306, how do I get this? Aha, look, they're supplementary. They add up to 180 degrees. But oh, I wasn't working in degrees. So I could have changed this to degrees, but I wasn't working in degrees. 180 degrees, though, is equal to pi radians. So this angle plus this angle has to add up to pi. So my angle, let's see, what should we call it? I'll call it alpha. Alpha plus 0.306, together they have to add up to pi. So I can get this angle, the one that also has a sine of 0.3011, I can get it by subtracting this from pi. So alpha is going to be pi minus 0.306. So there are actually two angles that have a sine of this value. And we know that because of our unit circle. All right, so I'm going to do pi minus that 0.306. Now, where was that? There it is. Enter that in, and there it is. So alpha is equal to 2.84 if I'm writing it with 3 significant figures. But remember, I'm going to have to do this formula again to get the third side, and I'm going to use all of these numbers that are in my calculator. Okay, so I'm going to do this again. So c squared is equal to 8.1 squared plus 12.3 squared minus 2 times 8.1 times 12.3 times cosine of this guy. Whoops, gosh, there I go off the edge again, sorry, of 2.84. Cosine of 2.84. All right, type it all in. 8.1 squared plus 12.3 squared minus 2 times 8.1 times 12.3 cosine, and then I need that number, need to capture it, there it is, and hit enter. Okay, so I get c squared is approximately equal to 406.9, but then I'm going to square root it. So square root, capture that quantity, put it in, and I get 20.2. 20.2. Remember, we always use 3 significant figures, 1, 2, 3. Okay, and so then my perimeter, my largest perimeter, is going to be 8.1, 12.3, and 20.2. Whoops, gosh, I keep going off the side. What is wrong with me? So my perimeter is equal to 8.1 plus 12.3, 40.6 centimeters. So this angle that we found here, it could have been small or it could have been big. Okay, so here I drew it small, but I could have made it like that. That would have been more to it. 8.1, 12.3, and 20.2. Because this side I could swing, or either one of these, I could swing it in or out. So this short side, I could have taken the short side, and instead of drawing it this way, I could have drawn it that way. See, that gets you the smaller perimeter. See this distance right here? This would have been the 5.18 right there. So there's 2 possible triangles. There's that possible triangle that I just shaded, or if I swung this side out and used the bigger angle, again, this is radians, I would have gotten 20.2 for this side. And there it is. Tricky problem. Boy, it's been a while. All right, all done.